Advanced LAN Configuration Part 3. The Catalyst 3550 Advanced Features. This is where we step it up a notch and show you just how capable this switch is of competing with any broad market router that's out there, except for WAN connections. We're going to talk about switched virtual interfaces, which, oh, it's going to change your life. How this switch can communicate and handle VLAN interfaces is amazing. And that's going to integrate right with configuring the routing and routed ports, because when you have the enhanced the EMI image for this switch, it is fully capable of handling any routing protocol that you want to throw at it. This thing can do OSPF, EIGRP. It does some amazing configurations with that, and any port on there can be considered a routed port rather than a switch port. So we're going to set that up. Finally, we're going to get into some of the advanced access control features. And I'm not talking access lists here. Don't think about and think, oh, I know how to configure access lists. It's not access lists. We're at the CCIE level at this point. I'm going to assume you already have that foundation knowledge of knowing what access lists are all about and setting them up. I want to step it up and show you how you can control access even within a VLAN on a switch. It's going to be some amazing stuff. So let's get going. So let's talk about configuring switched virtual interfaces, or also known as SVIs. Now, some of you may have configured these before, some of you may deal with them on a regular basis. Myself, I actually come from an environment that has the older operating systems a lot, with the Catalyst OS on a lot of their switches, on the 5500 and 6500 switches, or maybe some of the older 2900 or 1900 series switches that just don't have SVI interfaces. They have just a single IP address or an SC0 interface. So this may be a new concept for some of you. If not, then let this be a good solid review as we get into true multi-layer switching, because that is what they're used for. What you see at the top is an SVI is a virtual interface representing a VLAN as a single interface. And it can be used to route between VLANs or for management. So I've got my bullets out of the way. Let me get into what this looks like and do a show IP interface brief. In one of the prior nuggets, we went ahead and configured an SVI. VLAN 128. A VLAN interface is really an SVI. VLAN 1 is on the switch by default, but Cisco says don't use it, so we'll take their advice. We have this being used solely as a management VLAN and solely as a management IP address, so that we can remotely manage this switch by telnetting to that IP address. Oh, but it can be used for so much more than just that. Switch virtual interfaces are what make your switch truly layer 3 capable. Let's create a couple of them. I'm going to go into global config and type in interface VLAN 100. And we'll assign an IP address. We'll say IP address 192.168.1.1. So we've created our first SVI, well, our third, I guess you could say, SVI interface on this switch. And what is it doing? It's representing the entire VLAN 100 as a single interface, and more direct, at layer 3, a single IP address that can be used. Let's create another one. And I am going to be using this in just a moment. Interface VLAN 200, and we'll just say 192.168.2.1. And you can see these interfaces have come up, and we've now created two, I guess you could call them, routable interfaces on our switch. I got to pull back the curtain and show you where I'm going to use this. Let me bring up the topology for this environment. We have our multi-layer switch sitting right here in the middle, 3550 switch. We have two VLANs really created, VLAN 100 and VLAN 200 over here, with 4 switch ports being run to each of these PCs down here. Over on the right-hand side, you see the 3550 switch, which is what we're on right now, and it's 2 VLAN interfaces with the IP addresses that we just assigned. But it gets even more exciting than that. Look at this. Fast Ethernet 0/3 is directly connected to a router which connects off to the internet. That interface on our switch has an IP address. No, I'm not talking about an SVI there. I'm talking a truly routed port. We converted that port to a router port on the switch, and oh, we're even going beyond the SVI interfaces already. So let me stick back and get back to what our switch is capable of right now without bringing this router into the picture. Our switch is fully capable of routing between these VLANs, of routing between VLAN 200 and 100. Now, I do want to make sure that you know, in order to do that, in order to route between these VLANs and expand it into the great beyond and receive routes from the internet and so on, we need to have the EMI image on this switch. And as I mentioned in a previous nugget, this is the enhanced image that allows you to do a lot of layer 3 capabilities and run very advanced routing protocols. But as of right now, our switch is able to route and segment VLAN 100 from VLAN 200 without a router in between. I mean, I look at this and it kind of looks like a router on a stick, but it's not really. It is just a router that is connected to the internet that gives us WAN connectivity. This router plays no part in routing between, sorry, I need to change my pointer there, in routing between the VLANs at all. The switch is handling that all within its own internal switching logic, which gives us a huge bandwidth increase because we're not taxing that 100 megabit per second line with all the traffic from the VLANs. So I want to configure, let's step beyond the SVIs because SVIs are very straightforward. As of right now, I didn't even configure routing, and this switch is capable of moving traffic between VLAN 100 and 200 and 128 to do local traffic. And that's considering that I've gone to global config mode and typed in IP routing to let it know you are capable of IP routing in the layer 3 functionality. Now I'm going to get into interface fast Ethernet 0/3 and type in one mega command that converts this port to a routed interface. I'm going to type in no switch port. By doing that, what I've done is I've now made this capable of routing to this router. I almost want to say it looks like a crossover cable should be connected because this is acting as a router to this router. But no, you still use straight through Ethernet. Now, at this point, I can go ahead and say it has the IP address 172.16.1.2. Class C subnet mask. And let's see what this looks like in a show IP interface brief. Look at this. It looks like a switch port. It feels like a switch port, but there, to our dismay, or our amazement, I should say, is an IP address. It's now capable of handling layer 3 functionality on that switch port and connecting to that router. Why is that good? Because this switch can now receive a full routing table. Look at this. I'm typing show IP route because right now it only knows about its connected interface. Its SVIs are sitting on those VLAN interfaces, and it's using one physical interface, fast Ethernet 0/3, that it's using to connect to the router. But we can expand that. We can allow it to start using EIGRP. I'm going to choose that routing protocol to receive what routes this router has to tell it. The only configuration that we need to do is to set up the routing protocol on that 3550 switch. I've already gone out here to this router and set it up as EIGRP Autonomous System 90. So if I type in router EIGRP 90 and just do a simple network statement, network 172.16.0.0, and let's do a no auto to turn off auto summary. And at this point, I'm anxious to type this in. I give it a sec to replicate. I'll do a show IP route. Wow, look at that. I just get so excited every time I see that. Look at this. This is a switch. The name tells you, 3550 switch. It's a switch, but is it? It has dynamic routes that it's learned from that router. Look at this. All of these 172.16s, yeah, they're not truly internet routes, but you get the idea. They could be. And this switch, is it even a switch? No, it's a router at this point. It is now able to route between these VLANs and into the great beyond or whatever is out there. Look at this. I can even get in here, do an IP route, all zeros, create a default route and say, I need to go to that router for whatever routes I don't know about locally. So at this point, I've now introduced even a static route into the mix so that if any of these routes don't satisfy me, I can go to that router to get to something like the internet. At this point, we now have created an all-in-one device using a combination of switch virtual interfaces right here and a routed port simply by typing in no switch port, and we can do that on as many interfaces that you want to. That's the power of using this 3550 switch, which is far more than a switch, and I think we realize it at that point. Now, before we go any further into our next topic, let me answer a couple questions I'm sure many of you are asking. Yes, I do drink a lot of coffee, and yes, I do occasionally twitch. Now, the next topic I'd like to discuss is one of access control. Access control. Now, access control, when most people think of it, and they think of it in the Cisco environment, they think of access lists. And let's review that. We have standard and extended, and even beyond that, access lists that we can use to deny traffic as it's going from one network to another. So for instance, an access list could deny this computer from accessing that computer. And we could even get more granular than that. I could say I want to deny it from just accessing it using HTTP or FTP or Telnet or something like that. We can get pretty detailed using an access list. And that works perfectly fine on this switch. We can apply an access list in incoming and outgoing directions on any switch virtual interface, on any one of these interfaces that I want to. Now that's great if I wanted to allow and deny traffic going between networks. But could it be possible? Could it be possible to even allow and deny traffic to and from the same computer in each VLAN? What? Traffic to and from a computer within a VLAN, so it's not even leaving its own network and it's being allowed and denied? It's too good to be true. No, it's not. It's reality, and we can do it on a 3550 series 3550 switch using something called a VLAN access map. Now this is a pretty advanced topic, and if you've never heard of a route map before, you might want to check out some of the BGP nuggets and some of the advanced routing nuggets, because this follows a very, very similar scheme to a route map. And I'm going to walk you through it step by step. First off, before I do, let's give these guys IP addresses. Let's say this is 192.168.2.2, and this is .2.3, so we have something that we can control in here. Now what I'm going to do is get into global configuration mode, and the command to create a VLAN access map is this. VLAN access map followed by a name. And I'll say deny traffic. That's my name. Then we can use a sequence number, which is really handy because this allows us to add and remove statements. It's an ordered list, just like an access list, but I can add and remove statements as I need to if I need to modify this list later. So I'll start with sequence number 20. That allows me to enter up to 19 statements before that if I need to. So I'm in access map configuration mode, and there's two major commands that we're going to use from here. Action is the first one, and match is the second one. Under action, we have two possible values, drop and forward. If I want to deny access, I drop, and if I want to allow, I use forward. And as I mentioned, in this scenario, I wanted to deny the computer with the IP address of 2 from reaching the IP address of 3. So I'll say action drop. Now, we've given it its action, but now it needs to know what action to take that on. I need something to match. And in this case, we're going to match an IP address. And yes, I already see your minds going, MAC-based match? So we can match MAC addresses too? Yes, we can, but I'll get to that in a second. Let's start off with an IP address. Let's say match IP address, and in this case, we use an access list to match that IP address. So we're kind of integrating multiple things into this scenario. So I'll say I want to match IP address, and we'll say 101. We'll use an extended IP access list. So let me exit out, and I'm going to say access list followed by 101 to say it's an IP extended access list. And this logic is going to get a little bit funny. I'm going to say permit, because I'm going to permit somebody to be denied. We'll say IP. I'm going to permit anything using the IP protocol from host 192.168.2.2. That's this fellow right here. And I'm going to say anytime that host is accessing host 192.168.2.3, which is this host right here, I want to match it. Now let me make sure I go over this logic with you. I just created access list 101, which is permitting this host. So initially, looking at that logic, you're thinking, okay, you just permitted that host to access 192.168.2.3. This is where the logic combines. I'm actually permitting that host to be denied. Look at this. Make sure you combine these two statements up here. I have an access map, deny traffic. What action did I take? The action is drop. What did I match? I matched IP address, or access list 101. So any access list that I match in here, I'm going to drop. See, if I would have put deny in that access list down below, then what would have happened is it would have denied that person from being denied, from being dropped. So you've got to, it's strange logic, but that's how they combine together. And at that point, I've now denied that host from accessing that host. But wait, there's still an application that I need to use. I haven't told it what VLAN it applies to. This is the final command that we need to use to set this up. I'll type in VLAN filter, followed by the name of the filter that I use, and I think it was deny. Was it deny traffic? Yeah, deny traffic. That's the name up here. So I'll type in filter deny underscore traffic, followed by what VLAN list I'd like to use. I can say what VLAN I want to apply this to, one or more VLAN. So in this case, this is applied to VLAN 200. I hit enter. I have now denied traffic within a single VLAN. So at this point, using the IP protocol, computer 2 up here will not be able to access computer 3. But what if that's not good enough? What if the IP protocol, while it is used for many different attacks and many different access attempts to computer 3, it's at layer 3. What if we suspected that this computer number 2 is attempting to hack computer number 3, even like at the NetBIOS layer, down at layer 2, or using a Mac level attack? At that point, you might wonder, what are they doing on our network? But that's beside the point. Let's get into the Mac access list and how we can control access even down at the MAC layer, because this is a switch and a router. We just implemented router style filtering up at IP, but we get it even better than that. We can create a VLAN access map, and I'll say this one, I had deny traffic before. I could even append to that same one, but let's create a different one. Let's say deny MAC, and I'll use sequence number 20. And what I'm going to do here is I'm going to say action is drop, just like we did before. And I'm going to type in match, and this time instead of saying an IP-based match, I'm going to type in MAC. Match MAC address, followed by an access list name, because MAC addresses can only be grouped together typically in named access lists. So let's just say invalid MAC is the name of our access list. Now I'm going to exit out, and I'm going to create that access list. I'm going to type in MAC access list extended, and I'll name this invalid MAC to match our VLAN map that we're creating up above. Now inside of here, again, using that reverse logic, I'm not going to deny the MAC. I'm going to permit it to be denied, because I'm combining it with the drop that I created before. So I'll say permit, and we'll just say the MAC address of that computer is 00E0-1E58598A. That's the MAC address of computer 2. And I'm going to say that one is permitted to be denied when accessing. I don't want to deny them from accessing other computers on this subnet that may or may not be shown in this diagram. I'm just going to deny them from computer 3. So when 00E0, etc. accesses 00E1 6543, at this point I'm just making one up, 1234, enter, it will be denied. Oh, and I needed to type in host. Permit host to access this host. It's just like an IP access list. We can use wildcards and things like that. So in this case, I'm going to say when this host is trying to access this host, they are permitted to be denied. Exit out of that MAC access list configuration mode and type in one more command. VLAN filter, and I'll say the filter that I'm going to be applying, I forgot the name already, is DenyMac. And that will be applied to VLAN, and we can type in a list or just 200. So what have I done? I want to make sure I've brought everybody along with me here. I have, number one, created an IP access list that denied computer 2 from accessing computer 3 at anything at the IP layer and above. And then I also created a MAC address list that keeps computer 2 from accessing computer 3 at layer 2 and above. So you might be thinking, isn't this a little redundant? If we created a MAC access list to filter computer 2, wouldn't that include anything that it could do at IP? Because eventually it has to get down to layer 2 to communicate. The answer is yes, it is redundant. It is too much security in this case, because what I just did using the MAC access list is more than enough to deny computer 2 from accessing computer 3 in that example. But by seeing that example, you are now able to deny them at layer 2 or layer 3, depending on what your requirements are. As we wrap up our security feature section on this 3550, I want to take a turn into what I call my secret ninja command department and talk about some of the security features that not many people know exist on this 3550. Well, hey, we've done a pretty good job so far. Not many people know about that VLAN access list we just talked about to control access within the VLAN. But to do this, let me change over to a clean slate of this topology and talk a little bit about this. There is a mode that we can put our ports in that is known as switch port protected mode. To do this, let me do this. I want you to imagine that this is all one VLAN. Instead of having two VLANs like we've been having up till now with VLAN 100 and 200, just pretend that this is all VLAN 100 and all these computers are on the same subnet. So I'll say this is 192.168.2.2, 3, 4, and 5. Now you can deploy a mode called switch port protected mode. And here's the idea. When we go into a port and we say that it is protected, that means it can only communicate with unprotected ports. For instance, if I go in here and this green circle means that I went into this fast Ethernet port on the switch and said this is protected. I'll put a big P. It is in protected mode. At that point, it will only be able to communicate with ports that are unprotected. So if I were to put this one in protected mode as well, these two devices cannot communicate. I like to think of it as they are being protected from each other. We've just put a switch-based firewall between these two that completely eliminates access. Now these unprotected guys that have not had protected switch port configurations can communicate just fine. It just keeps two protected devices from interfering with each other. It's great for high security environments where you don't want to get into the complexity of those VLAN access lists. Let me show you how to do it. It's just one command. I'm going to go into global config mode, and let's just imagine that this one right here is connected to, we'll say, fast Ethernet 0/5. I'm going to go into that port, and I'm going to type one command, just switch port protected. At that point, it is in that configuration I just mentioned. It can only communicate with other unprotected ports. I'll also do the same to fast Ethernet 0/6, and I have effectively cut communication. Even though those are in the same VLAN, communication is cut between those two ports. We can verify this just by doing a show interface, and this is a huge command, by the way. Show interfaces fast Ethernet 0/5 switch port. Always got to remember that switch port on there. And what we see down here is protected is now true. Typically that's false. Let me just show you one for comparison. I'll do fast Ethernet 0/8 switch port because we haven't done anything with that. You see protected mode is false. So this is an unprotected port which could then communicate with this protected port. And careful with this logic. It's hard even in my own head to keep straight. Protected ports cannot communicate with each other. Only unprotected ports can. Now since we're dealing with security, let's deal with this option that's right below it. Unknown unicast blocked and unknown multicast blocked. If you want to go all out with security, you can turn on these features. See, when a switch receives a packet for an unknown MAC address, like a multicast or a MAC address that hasn't been discovered yet, what's it do? Well, it sends it out all ports, right? Since it doesn't know where that packet goes, it's going to send it everywhere. Well, if this protected guy tries to hack this protected guy, and it knows that it can't communicate directly, it will then start sending frames to unknown MAC addresses, getting the switch to send it over, thinking that it needs to be flooded everywhere. By turning on these features, unknown unicast block and unknown multicast block, it will block those respective packets. If the switch doesn't know where it's going to go, and it's a unicast, and you have this enabled, it will not send it out those protected ports. Again, it's a very easy feature to enable. We go under interface, fast Ethernet 0/4 is the one I believe I've been using so far. Just type in switch port block, and you have your option there, unicast or multicast. By doing that, that feature is now turned on, and it will keep packets that are sent to an unknown MAC address from being sent to this it must have been a different port, fast Ethernet 0/5. But either way, this keeps the unknown MAC addresses from being sent out those specific ports. In this nugget, we have discovered that the 3550 is a pretty spectacular device. It is capable of full switch features, full routing features, and more. And for a stackable switch, that's just spectacular. That's the only word I can use to describe it. Sure, you can buy the $100,000 chassis that do similar functions, but man, it's a lot of power packed into a box. We started it all off with switch virtual interfaces, and just to hit the high points, those SVI interfaces are your logical connections to get you off VLANs. They're your routed interfaces that you can just make up as an administrator, and the switch will be able to route to and from those interfaces provided you have the EMI image. We also talked about configuring routing and routed ports, allowing the sync to accept, in our case, the EIGRP routing protocol and receive updates from our routers on our network, providing it the ability to be even a core switch, a stackable core switch in a large enterprise network environment. So it's very capable of handling routing updates and routing ports to connect to routed devices. We wrapped it up with many ways that we can implement Catalyst 3550 access control, including the VLAN access list, allowing us to block access to and from devices on the same VLAN. That's the amazing thing about it. Based on the IP address, based on the port number if you're using an extended access list, or even based on MAC level information. So you can even block down at layer 2 to cut those layer 2 communications. We also talked about the Secret Ninja configurations of switch port protected mode and blocking the unicast and multicast traffic. So I hope you've enjoyed this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.